On Hot Science today, we watch the zoo vet at work, we take a look inside the human body, and I see and Pooh do a good deed.
Hi and welcome to another great episode of Hot Science. Yeah, hi, and let us introduce to you Bonaparte. Now, Bonaparte is a very important member of the Hot Science team. You may have seen him hanging around the lab at times. And Bonaparte, as you can see, is an example of a human skeleton. Sure is. He's got ribs just like us, a pelvis like us as well, and leg bones too. Actually, this is the longest bone in a human body, isn't it? It's called the femur. Yes, and it actually gives a quarter of our height. The femur. Now, the smallest bone in the human body, if Bonaparte had ears, it would be in his ear, or it's in our ear, and it's called the stirrup bone. But about a quarter of Bonaparte's bones and your bones are in your hands, and another quarter are in your feet. So if you add them up, half your bones are in your hands and your feet. Now, if Bonaparte was real, he would have 206 bones, which is what Sue and I have. But as small children, we actually had 300 bones. But then some of those bones fused together and we're left with 206 when you're grown up. But we've got some real examples of skeletons just over here. Come and join us over here and have a look. We've got some human bones. Now, this is a human skull. And look, I can even move the jaw by going like this. This is actually real, I should tell you. Hello, Robin. I was missing some teeth there. Yes, I'd have a list, wouldn't I? Yes, you would. And we've got some other bits and pieces. Yeah, now this is the thigh bone that Sue was talking about. It's the biggest bone in the body, and it's attached here to the hip. Okay, so that's part of the pelvis. We've also got some ribs, so these would be a few spare ribs that we've found. That's a little bit of a joke. And these would actually sit somewhere up about here on my body, and they're there to help protect my organs like the lungs and heart that are inside my body, and that's an important thing that skeletons do. Yeah, it is. And this one here is the backbone. Now, as you can see, I'm actually holding what would be the spinal cord, and the vertebrae and the backbone go around the spinal cord and protect it. So that's spinal cord taking messages from the brain to all the muscles through the body. And you can see it's got a nice curve, so that's a fairly healthy looking backbone. Yes, and of course the backbone allows us to stand up straight. And when we're children, there are 33 vertebrae in the backbone, but when we're adults, it goes down to just 26 because some of them fuse together. We've also got some other skeletons over here. This is a koala skeleton. And I guess what's really important about this is have a look at the backbone. It's very curved. And down the bottom here, you can see that some of the vertebrae have adapted so that the koala can sit comfortably on a tree. Yeah, so it's got a modified pelvis as well. And another interesting thing about the koala, if you look at its hands here, is it's actually got 2 thumbs on its front legs. And that would help it to hang on to the tree, I guess. Oh, wouldn't that be great? You could hold all kinds of things with that. Also, down here we have a snapper, or a fish, and this has got a really interesting sort of array of bones here. Yeah. And this really weird thing on the top of its head. Yeah, one thing about grown-up snapper is that they have a bony lump on the back of their head. Have you seen them at the markets, or if you've been fishing you might have noticed a snappers? Do we know why? No, I don't know why. Just a weird thing that's got on top of its head, I guess. And you can see the backbone has these long bony protrusions which help give the fish shape. We've got another animal here, though. This is a lizard. Now, all the animals we've looked at so far, Rob, are animals with backbones. They're vertebrates. And this is another, a lizard. You can see the very long backbone going all the way, way to the tip of the tail. And also a little frog here. Now, frogs use their legs to jump around. Their legs are really important. So you can see this frog has very long and quite strong leg bones. It's got very long fingers and feet too, hasn't it? Yeah, so it can cling onto trees. Yeah. Well, not all animals have got their skeletons inside their body, Rob. And this is one of them. Now, this isn't a vertebrate or a backbone animal. No, it's an invertebrate, isn't it? Yep. And it has its skeleton on the outside. Now that causes a little bit of a problem for the animal because as it gets bigger, it's got to get rid of that hard shell so that it can get bigger. So during its lifetime, it has to molt and form a new skeleton. Well, as you can see, skeletons come in all different shapes and sizes, and without them, well, we just wouldn't be here.
Skeletons.
And where 2 bones meet, we have something called a joint. Now, sometimes these 2 bones actually fuse together, and that happens in the skull. Here's a model of what would happen. When you're born, the bones are separate, but fairly soon after you're born, those bones actually fuse together. Looks a bit like a jigsaw puzzle, and we can show you that with our skull here. You see these little bone plates, and this is obviously an adult one because they have fused together. Yeah. Okay, well, a different sort of joint is the one we find in the backbone. And here's a model of that. We've got one vertebra, another vertebra, and in between we've got some soft spongy material which is called cartilage, and the whole thing's held together by ligaments. And you can see that I can move this joint by pushing and pulling like that. It's a bit harder though to tilt it from side to side, so that's a different sort of joint. Well, that's how it is in real life really, because I can go forwards and backwards, but it's a lot harder to go side to side. All right, well, another sort of joint is called a ball and socket joint. I've got a model of that here. You can see there's a leg bone. This is the femur, the one that goes up to the pelvis. It's got a rounded head, which we call the ball, and it fits into the pelvis, which is shaped a bit like a socket. So you can move this joint like that. Rather squeaky joint, that one. That also happens with our shoulders as well as our legs. And you can see one down here. There's the ball there, and it fits nicely into this rounded socket. And to demonstrate, you can move your leg forward and backward. You can also do a bit of a round and round motion like that, and the same with your arms. Okay, well, one other sort of joint that we've made is a hinge joint. And this joint, you can see, it's just like a door hinge. It's the elbow of this arm, and you can move it just like a hinge. Now, what's important with this one is the rubber bands which are representing the muscles. That's right, because if you want to use or move your bones, you've got to have muscles to do that. Now, muscles can't push, they can only pull, so they're organised in pairs to be able to do lots of different movement. You watch what happens when I pull on this top muscle on the inside of the arm. I can bend the arm. The muscle that's on the other side of the arm, I pull on it, and it relaxes and this one works. So there's muscles on the inside and on the outside, and by using them together I can do lots of different movement. You might be able to feel that if you move your arm in and out like this. See if you can feel those two different muscles working. Have you ever pricked your finger with a needle like this? Ow! It hurts, doesn't it? But there is a form of ancient Chinese medicine that uses needles like this to help heal the body. It's called acupuncture. According to traditional Chinese medicine, the human body has about 1,000 acupuncture points located along the meridians or lines of energy that run through the body. By inserting special needles at these points, the body's energy can be stimulated to help the healing process. Acupuncture is used to treat many different conditions, such as headaches, back pain, stress, and asthma. The needles are made of stainless steel and come in a variety of sizes. For example, very fine needles are used in the ears, larger ones for the hands, neck, back and chest, and the largest size are used in the legs and buttocks. Professor Chen, who's been studying acupuncture for many years, starts by swabbing the area. He then inserts the needle, being careful not to pierce any blood vessels, nerve cells or major organs. In this way, the patient shouldn't feel any pain. The acupuncture points used may be close to the pain or distant from it. It all depends on which meridians are involved. So tell me, does it hurt?
No, the majority of times it doesn't. On some occasions you get a very slight sensation, and it's all no hurting sensation.
Doesn't feel like if you were to put a pin in your own finger, like a pinprick?
No, nothing like that at all.
After 20 or 30 minutes, the needles are removed. In many cases, a series of treatments is required. But for our patient, the treatment is over, and his injury will soon be just a memory.
The Adventures of IC and Poot. IC and Poot were playing in the backyard when IC noticed some grass sticking out of the roof of the shed.
Hey, look, Poot. A bird has built a nest on the roof of the shed.
She looks like she's got some eggs in the nest.
If it rains, the nest could get washed away.
Or could we shift the nest to a safer place?
We'll need to make a tool to lift the nest down without damaging the nest or the eggs. Could you try to do that, investigators?
So IC and Poot need a nest mover. Well, have you got any designs we could test? We do have a team of investigators. They're from Ardtornish Primary School. We've got Tammy, Jessica, Michael and Damien. Let's go and see how they'd tackle this one.
We are here to help Icy build a device to get his bird's nest down from a gutter. We are going to use some timber, a gripper, cardboard box with some padding in it for support for the bird, and a brick.
We're building a device to help RC get a bird nest out of a gutter, and these are the materials we're using. 4 bits of timber, some nuts and bolts, a drill, and a spanner.
Next on Hot Science, we join the zoo vet.
Just like most babies need vaccinations, young zoo animals are no different.
What's happening now is we're trying to separate the young one from the parents. As you can see, the parent's got, particularly the male, well, only the male's got a large set of horns. Anyway, he's in now. We get mum to go, and then once we've got the kid out in the exhibit, we'll be able to put a net up, and hopefully he or she will run into that, and then we can get down to business. Okay. Okay. Little boy. This is a tetanus vaccination, and it's amongst other things as well as tetanus. Most important for young antelope. Now we do the microchip so that we've got an identification, and that goes onto the left side of the neck, just behind the ear. That's a fairly constant positioning throughout the zoo world. And we just push the zapper over. Got a number 124 0BA6 of astringent anaesthetic cream.
Got to cut the corners up quick.
Yeah.
You know, just running on.
Okay, so then we'll get a little bit of a jump here. Okay, this is designed to give us field identification. And we trim it down. It's a tiny little tag, doesn't worry the beastie at all. We did 4 things. The first thing was vaccination. That's the most important, against the clostridial diseases, including tetanus, most importantly tetanus. We then microchipped him so that we've got permanent identification of that animal. Third thing that we did was put a little ear tag in so that we've got field identification. And the 4th thing we did was sex him, make sure that he is a male.
With the examination and tagging complete, the baby kid is released and reunited with its family.
What we're going to do now is vaccinate the chimps against polio. So how we're going to do this is orally. You know, when we did the antelope, we used an injection. This time, we're going to use an oral vaccine. So we've drilled a hole in this banana here, and we just put a couple of drops into it. Oops, that's right. And mix it up into the banana. And we're going to throw these into the chimp colony. And with a bit of luck, they'll all take a dose of vaccine. Now, it is so important that we continue the vaccination of our animals against some of the infectious diseases.
When touched, the sharp quills of a porcupine come off and hook into the attacker's flesh.
Propulsion.
Propulsion? Oh, hasn't that got to do with, like, moving things with propellers and things like that through air?
Sure does.
Oh, hi, Sue. Yeah, it has got to do with that, hasn't it, Sue?
That's right. When we propel something, we move it. We can move it through the air or the water. And we can have jet propulsion engines on aeroplanes and powerful boats, but we can also propel things like a balloon. It can be as simple as that.
Really?
Well, let's suppose I blow the balloon up. Actually, I'll do it.
Wow.
That'll do.
Okay.
Now, we can propel the balloon through the air by letting it go. As the air in the balloon rushes out of the nozzle, it pushes the balloon the other way. You ready?
Yeah, let's go.
3,
1, 2, 1, go!
That was a bit quick. So we propelled the balloon. But speaking of propulsion, Robin's been designing a gas-propelled boat.
Let's take a look.
Yeah, now Sue, we're going to make our gas-propelled boat, and what we're using is carbon dioxide gas. So to make our carbon dioxide gas, we have got some bicarb soda. So would you like to spoon some bicarb into this tissue here and make something that looks like that?
Sure, okay.
And while Sue does that, I'll show you our boat here. Now, all I've used is a drink container. And you see at one end here, I've put a hole, and through the hole is a straw, and then I've sealed it with modelling clay to make it airtight. And it is really important that our little boat here is airtight. So our bicarb and bicarb soda and vinegar can work together to cause our chemical reaction. So how are you going there, Sue?
I've just finished, so I've got a cylinder full of bicarb there. Like
Yep,
that, right?
And the other thing we need, as I just mentioned, was the vinegar. So would you like to pour some vinegar in here for me? Now you need to make it to about there, so I'll sort of tell you when to stop.
Okay. Oops, someone's dribbling out this end. How's that looking?
No, a bit more. Stop, stop.
Okay. It smells nice.
Yeah, it smells a bit like fish and chips, doesn't it? Now, if I just put our boat in the water like this, what I need you to do is put your little capsule,
this thing,
in the top here.
Righto. Okay, so it's pretty fragile. It's just made out of one tissue. Okay, slide it in like that.
Yeah. Push it in.
Ooh. Okay, like that.
Now, I'll give it put the lid on, give it a quick shake. Oh, see what's happened?
Oh, wow.
See the bubbles?
Yeah.
And our boat moves along. Now, what's actually going on inside here is the bicarb soda is mixing with the vinegar. A chemical reaction is happening. We are producing carbon dioxide. Because we made our boat airtight, there's nowhere for the gas to go except out that straw. Those bubbles, if we push the straw back into the water like that, are the carbon dioxide gas, and it's propelling our boat forward like that.
Sounds great too. And one of the really nice things about this is the equipment is something you'd find in the kitchen. Bicarb soda, vinegar and an old soft drink bottle. And you could launch your gas-propelled boat in the bath.
Space. People walking on the moon, people flying around the moon, rockets burning engine fuel, rockets flying back to Earth, and people looking up so high.
Here's a close-up puzzle that'll really tickle your mind. It's a useful covering of many colours. Did you guess the mystery close-up? Well, here it is. It's a feather. And feathers come in lots of shapes depending on what the bird uses them for. In lots of species, the male bird has brighter feathers to attract the female.
I wonder if our investigators have come up with a tool to lift the bird's nest down without damaging it.
We made a nest catcher and we used 2 bits of timber and we put 2 bits of timber on top. And then we joined this bit of wood and put a cardboard box with padding in it for the nest to go in. And then we put 2 bricks on it to keep it up.
This is the other part of the nest catcher. It has 2 long bits of timber joined together by a nut and bolt. Here we have 2 pieces of wood with grooves in it, and those will help to have to get the nest easily. Here we have 2 bits of string, which will be for people who can't hold the nest catcher very well, so they can hold it like this, and if they lose it, they'll still have the nest catcher on them. Now we're going to give you a demonstration. I grasp the nest with the gripper. Notice that the grooves help to pick it up easily. I come around here and place the nest into the cardboard box, which is padded. When it is firmly in there, I let go of the nest, and it makes a very nice spot for the birds and the eggs to hatch.
This is our device to get a bird's nest out of the gutter, and this is how we made it. We got 4 equal lengths of wood, drilled some holes and put bolts in it and put some nails for grip. This is the lever action. And this is how it works. And then put it up into a nice safe tree.
Well done, investigators.
It's Great. Can you tell me 2 different types of joints that we find in our bodies?
Sure. I've got a ball and socket joint in my shoulder and hip, and I've got a hinge joint in my elbow. Ah. Now, Ooze, I've got a question for you.
Okay.
Do you remember the chemical reaction that Robin used for her bubble-powered boat?
Oh, yeah. It was vinegar and bicarb soda.
Well done. And what did we get?
Carbon dioxide.
Ah, Ooze, you're amazing.
Thank you.
I've got lots of little bubbles.
Yeah, I'll try and blow some now for you.
Okay, go on.
Oh, yes!
And Sue, what have you got over there?
I've got a message coder. Now, I like sending secret messages, and this is one way to do it. I've got 2 circles made out of cardboard, and you can see one spins on top of the other. I've divided each of them into 36 equal parts. So I've got all the letters of the alphabet, A through to Z, and the 10 numbers from 0 to 9. And what I can do is actually line up, say, P with the number 4, and now I can actually send a message. So if I want to say D, I could use Y. Or F, I could use O.
Can we do Ooze?
Yeah, do Ooze, do
okay,
Ooze.
let me see. Ooze, I'd need 9.
Yeah, for
9.
O. 9.
The
E?
Oh, no. 9. Where's Z?
Oh,
Here
okay, there it is,
K,
down there.
And then Z.
Yes!
99KZ.
Well, that's something for you to try. Make one of your own encoders and try it on your friends.
Yeah.
Anyway, we have to go. We'll see you
Goodbye.
next time.
Bye.
Bye-bye.